Okay, so this is just going to be a few random problems I saw you guys asking about. This first one, 69, on the factoring page, you have x to the fourth minus x cubed plus x minus 1. When you have the situation of 4 terms and you really don't have any GCFs to take out, your only option right now is to check and see if you can factor by grouping, and that's what this one is. So factor by grouping is the formal method. I think Mr. Bartholomew last year called it the squiggly line method. You may have heard when you did split the middle, someone might have called it that as your factoring. Lots of different methods. But general, to factor by grouping, you just look at the first 2 terms and the last 2 terms. And we're going to look at the GCF of both of these groups and then factor that out. So you look at these first 2 terms, and the GCF of x to the fourth and x cubed is x cubed. Second one, x minus 1, the GCF is just 1. There isn't anything extra we can take out. So we factor both of those out. First term is factor out x cubed. When you factor that out, you're left with x to the fourth divided by x cubed is just x. X cubed divided by x cubed is just 1. So you're left with x minus 1. Then this next group return, you take out a 1. And you're left with the same thing, x minus 1. If factoring by grouping works, and you did it right, these 2 parentheses should be the same. That's the whole point. Because now our second step is to do a GCF again. So in this case, the GCF is x minus 1. So we just take that on out. We have an x minus 1 out front. And then we are left with x cubed after we take it out and plus 1. So your factored expression is x minus 1, x cubed plus 1. This next one, on the second page, you've heard a lot about 113. So this is still another rational expression. In order to solve this, we have to get all the fractions combined, meaning we need common denominators, and then we'll be able to cross multiply and get rid of the fractions. So yes, we're solving for x. There's x's all over the place, but since it's in the denominator, we know we're going to have to get rid of that. So in order to add these, we have to multiply by what's missing. Whoops. That should say x minus a, x minus a, and x minus a. Technically, those should all have parentheses. Just be careful that you know that we would have to multiply everything out if need be. So now we can go ahead and add these together because we have our common denominator of x minus a and x plus a. So we get x plus a from the first fraction. We get x minus a from the second fraction. And this is all over x plus a times x minus a. Now, we can just simplify this out a bit. So if we have x plus x equals 2x, a minus a goes away. Also on the bottom, normally I would say never multiply this out. It makes it easier not to. However, in this case, you should notice that this is a difference of 2 squares. That's a special case. So multiplying it out actually makes it easier. With this just multiplies out to be x squared minus a squared. So that takes out some of the bits. Now we have a single fraction equal to a single fraction. We can just cross multiply, expand everything out, and then we'll be able to solve for x. So we have 2x times x minus 1 on one side. We have 2 times x squared minus a squared on the other side. Let's go ahead and distribute all these out. So we have 2x squared minus 2x equals 2x squared minus 2a squared. And again, don't forget about your end goal. We're solving for x. And now we can look at what's canceling out. So the 2x squared's 2x squareds on both sides. Or you can subtract the 2x squared to the other side. It would go away. Now we have negative 2x equals negative ax squared. Last step, we're isolating x. Divide by negative 2. And we end up with x equals a squared. Okay, last one in this little set to go over is on page 3, number 53. This is a multiply by conjugate problem. It's just a little bit more complicated of a conjugate. So remember, conjugate means we multiply by the opposite of that sign because the whole point is to get the fraction or get the radicals out of the denominator. So we multiply the top and bottom by x plus h minus the square root of x. I think parentheses. So now we have to FOIL this whole thing out. These are both special cases. So on the bottom, the whole point of the conjugate is to create a difference of two squareds. So we know that's going to multiply to be the square root of x plus h squared, which is just x plus h, minus, so remember it's a difference of two squares, so there's the first square. The square root of x squared is just x. So that simplifies out on the bottom. On the top, if we FOIL this whole thing out or double distribute the whole thing out, whatever term your math teacher used from the past couple years, we end up with x plus h. Now we have a double of the middle term. They're both negative, and this is where we are multiplying the square root of x times the square root of x plus h. We're going to have two of those. And then lastly, we have plus the square root of x times the square root of x, which is just x. So now we just have to simplify. On the top, this, we have two of the same thing. Then also when you multiply square roots, you just multiply the inside. So I'll show you off to the side really quick. This turns into this x times x plus h all under the square root. So if you distribute that out, we have x squared plus xh. So now for the rest of it, and there's two of those. So we have x plus x, combine our like terms, so that's a 2x. We have that h in there, so plus h. And then we have 2 of that square root x squared plus xh. It doesn't look pretty, but that's what you get, and that is perfectly fine. It's fully simplified. And then on the bottom, we just have to simplify this out. Notice we have an x and a negative x, so those go away, and we are just left with an h.